In this lecture, we'll try to cover average treatment effects, why we never directly observe them, and how a randomized control trial might help us observe them. So first things first, let's get some notation out of the way. So the random variable D will be used to for treatment assignment. So D can be either 0 or 1, and if D for a observation I is equal to 1, then that observation is being treated, and if D for an observation is 0, then they are in the control group. Okay, so this is dummy variable for a treatment and control, and I here is our observation or individual or our participant, subject, in any way that you want to imagine. Now secondly, there are outcome variables. Firstly, of course, there is an observed outcome. So this is something that we actually see in the real world. This is called observed outcome. The second one is potential outcome, and potential outcome are two types. So potential outcome can be potential outcome of untreated and potential outcome of treated, right? So this essentially means that it sort of asks the question, had you been treated, what would your outcome be? And had you been not treated, what your outcome be? So it's an entirely conceptual and theoretical question, that what would your potential outcome be depending on your treatment status. Okay, so if this notation is correct, we can try to understand average treatment effects and before that we should also expand this observed outcome. The observed outcome can be not divided, it can be it can be written in as a term of potential outcomes. So I can write observed outcome is equal to the dummy variable of treatment assignment times the potential outcome of being treated plus the dummy variable of assigned, 1 minus that dummy variable, times the potential outcome of not being treated. Okay, I hope this makes sense, because essentially here what we are trying to say is that the observed outcome, something we actually see in the real world, is a function of the potential outcome depending on your treatment status. So mostly this di will be 1, which means it is yi of 1 plus 0 times of yi of 0. That's mainly if you are treated. This is true if treated, right? So if you are treated, then your potential outcome of being treated should be the same as your observed outcome. I've just written this so that it makes sense, and of course your observed outcome will also be equal to your potential outcome of not treated if you're not treated. So that's a way you can think about this this expression over here, but this is not really important to us. This is just, I've just written it out so it sort of makes broad sense. Yeah, but let's go back to the main problem here. So what is the main problem? The main problem is that both yi of 1 and yi of 0 will never be observed simultaneously. So let me write that down. Both yi of 1, that is potential outcome of being treated, and potential outcome of not being treated, will never be observed simultaneously. Sorry, it's a bit long. Observed. Now, what does that intuitively mean? Let's think about it. So suppose you are studying if a business course affects a person's the businessman's sales. Okay, so our study objects are businessmen and or women, and we are essentially trying to study if we give them this business scores, will that boost their sales? So that's what we're trying and interested to study. The thing is, once you take a population of business people and you divide them into treatment and control group, and to the treatment group you of course give them this business scores, and to the control group they don't get this business scores. The treatment group will have a treated outcome, so we will observe the potential outcome of being treated in the treatment group. But for that same person, so imagine there's a businessman here and they got the business scores, we will of course observe what their potential outcome is when they are treated. But will we ever observe the potential outcome of them not being treated? No. Because they have been assigned to the treatment group, we will never ever observe this. So that means for this same person, we will never observe both their potential outcomes of treatment and control. This is a reality about the world. We cannot reverse time and make him not choose the course and have a counterfactual world where he does not do the course and then we check their sales, right? This is never going to happen. Now that is the main constraint in this field, and that is the main thing that randomized control trials try to answer. So if this problem makes sense, as in if this question is clear, we can continue on and learn about average treatment effect and how we might solve this problem.